All right, so here's what I'm going to do. I'm going to pass out your bell work. I'm going to take attendance. Guys, give me 5. Look up here, Cindy. Okay, I'm going to pass out your bell work, and then I'm going to take attendance. While you're doing that, I'm going to pass out some guided notes that we're going to do today to review working on factoring with a not equal to 1. We've been working on it for a day or two, so we should be able to get through that pretty quickly. And then what we're going to do, we're going to do an activity where we have a build a square puzzle, and you're going to work through that together in groups, okay? So that's going to be our goal today, is just to work on practicing with a not equal to 1. Remember, you have a quiz in your algebra class today, so this will be a good review for that. So right now, here's your bell work assignment. And this is a plan test problem, which, if you'll remember, we're going to take the CERN test here in a few weeks, and that's going to be the one that shows us whether or not you've grown this year.
Hey, can you throw like
Yes, actual. All right, here you go. And you want to put this way. Thank you. All right, go ahead and get started. I know that, let's see.
I already got the answer.
Deshaun needs an eraser.
I chose D. I need a pencil.
I've got a pen you can use. Mackenzie, do you need some more for this?
Oh, no.
Okay, can you get started for me? Colin, you need some the right way? Oh. All right. Thank you all for getting started. I'll take attendance and I'll be right back. And we'll work this out together. You need sharpening?
Yeah.
Here, I'll get it for you in just a second, okay? We're missing Michael, that's it, right? And Letitia?
Dang, how big was that?
Sounds like somebody's out of class.
I was like, somebody did it.
All right. There it was, right next to where I was. Okay, Mackenzie needs this. I'm going to go ahead and pass these out while we're finishing up, and then we'll go over the bell work problem and we'll get started. Here you go. Here you go. All right, so let's go over the bell work together. Y'all will look up here. Today is the 10th. I think. No.
Yes, it is.
Today's the 9th.
Today's the 9th.
Today's the 10th.
Oh, it is the 10th. Okay. My bad. Missed the whole day. But that's good, though. At least it wasn't the 7th. Okay. So, it says we got the figure below is composed of 3 squares and 2 equal angular triangles. If the area of each square is 36, what is the perimeter of the composite figure?
6.
Okay, the perimeter of the whole shape is not necessarily 6, but what is that? Mackenzie, why did you say the number 6?
Because the area, like, you gotta times it.
Okay, so the area of each one of these squares is 36. So you're saying we had to multiply 2 things together to get 36. What were they? 6 times 6, and that's because squares have the same length on both sides. Now that gives us a lot of information, okay? If we know that this is 6, what do we know about this distance?
6.
You're ready to say 6 a whole lot. What about right here?
6.
What about here?
6. 6.
Then we got these triangles. It says they're equal angular, which means that all these angles are the same. What does that mean about the sides? They're also the same, which means they're 6. So we got the same angles, same sides. Okay, now that is something you might remember from like 7th grade. I think that's whenever you all did equilateral triangles. Okay, so that's all of our sides except this one right here and this one right here. Now, do we know for sure how far it is from here to here?
No.
What about from here to here?
No.
No. Okay, Teresa, if you had to guess, how far do you think it is from, if you added from here to here and here to here? You say 6. You're right. Okay? Let's talk about why. Okay? If you go from here to here, how far is that? That's 6. How far is it from here to here? 6. Okay, so the whole distance from top to bottom, how far is that? 12. Thank you, Rebecca. But what do we know about this distance right here? From here to here?
6.
It's 6. Well, what's 12 minus 6?
6.
6. So even though we don't know for sure how far this piece is and this piece is, we know that if you add them up, you're going to get 6. So that gives us 1 extra 6, which I'm going to put down here. Now we're just going to count up the perimeter.
Okay, you add all that.
We add them all up. Thank you. So we got 6. So 1, 6, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixes, which gives us 10 times 6, which is 60. So our answer is D. Okay? So that was a fun little blast from the past, right? And those are the things we're just trying to dust off the cobwebs with those. Okay. So now what we are going to do, as soon as I find where I put that giant stack of papers, where they go? There they are. Okay, now what we're going to do, we are going to review these guided notes that I made for you. The reason I made these is because I wanted you to have the steps listed out really explicitly so that you would have them in front of you for the activity today. Okay? This is your last chance to review before your algebra test. Well, algebra quiz that you're having here in just a few minutes. Okay? All right. David. Can you sit up, please? Thank you. Silas. Thank you. All right. So we're going to fill these in together, and the way we're going to do it is I'm going to call on each of you randomly to make sure that we are all engaged and paying attention. Okay? So if you look at these notes, it says the first thing we're going to do is factor the expression 2x squared minus 3x minus 2 completely. Okay, step 1 says to multiply a by c. Okay, how can I find what a is, Austin?
It's 2.
Okay, it's, what was that? It's the first number, right. So a is the first number in the expression, and it's 2. What's c, Teresa? -2, and how do you get it? So 2 was the first, a was the first number, and c was the last number. Yeah, that's all you do to find your c. We don't have to do any math, you just have to observe. So we got our a is 2, our c is -2. Anna, what's that give me for a times c?
A times C. Or
Negative 4. Very good.
Let me put square.
Hmm?
The square.
The square?
Yeah.
No, remember, whenever you're finding your coefficients, it's just the number part.
Oh,
Okay? So you don't need the actual x's for this stage of development. Okay? But once we get down here, we'll throw the x's back in. Right now, we're just dealing with numbers. Okay? So now, we know that a times c is negative 4. So we need to find factors of which number, Dylan?
Negative 4.
Negative 4. And what do they need to add up to?
Negative 3.
Negative 3.
That's 1 and negative.
Now, what told you that it was negative 3?
B.
B. So we could say that they add up to B, and B is the middle number. So it goes A, B, C. All right, so we got our negative 3, and we've got our factors of negative 4 that add up to negative 3. Well, if we're going to get a negative number when we multiply these, what do we know about the signs of the two numbers?
one's going to be negative.
One's going to be negative, and one is going to be positive. Okay? So we know we're going to find factors of 4. One's going to be negative. One's going to be positive. So what are your favorite factors of 4? Zaire, give me a factor pair for 4. 2 and 2. And we know that one's negative and one's positive. So we got 2 and negative 2. What's another pair, Silas?
Negative
1 and negative 4.
1 and negative 4. Now, why did you make the 1 positive and the 4 negative?
So the 1 would
Let Silas answer. Thank you.
You're going to add 1 and negative 3.
Yeah, 1, because if you did it the other way, you would get 3. You'd get 4 and negative 1 is 3. But we're looking for a negative 3. 1 minus 4 is negative 3. What's 2 minus 2 plus negative 2? 0. Okay, well, but we were looking for a negative 3, so which factor pair do we use then?
1 and negative
1 and negative 4. Okay. So, now let's look at step 3. It says to rewrite the original expression replacing the b term. So whenever it says replace the b term, it means we're going to get rid of this negative 3. And instead, what are we going to put there, Jeremiah? I think we're caught here. Okay, we found our factors, 1 and negative 4. How do we use those to replace b? Well, b is negative 3. That's what we're trying to replace. What's another way of writing negative 3 that we found? Instead of negative 3, we can write 1 plus negative 4. Okay? So down here, instead of negative 3, we're going to write 2x squared. Instead of minus 3, we'll put plus 1x
And then
minus 4x. See how that works? We got 1x minus 4x. I'm not convinced of this yet. But stick with me and we'll see when we get there, okay? All right. So now we are going to group the first and second terms together and the third and fourth terms. David, can you please sit up, please? Thank you. That's the second time. Okay. So we got 2x squared plus 1x minus 4x minus 2. Okay. Whenever I say group, that's just a fancy way of saying put parentheses around it. Actually, that might be a less fancy way. There's fewer syllables. Yeah, whatever. All right. So now what we are going to do is we are going to factor out the greatest common factor from each grouping. Okay, Trebecca. In the first grouping, what numbers do I have in common?
1x.
Yeah, just a 1x. And what does that leave behind? Hmm? So we leave behind an x. What numbers leave behind? The 1 and a 2.
What do you mean when you say leave behind?
Whenever I say leave behind, okay. What we do, we find the greatest common factor. That's what they have in common. You see how we pull it out front? Think of it like, okay, it's all in a box, right? We find what's in common in the box, we pull it out. Whenever I say what's left behind or left in the parentheses, that's the stuff that we didn't use. So if we've got a 2x squared right here, and we take out one of those x's, Well, what did we not use?
The x, the 2.
We didn't use the 2. And then if I had an x squared, how many x's is that actually?
2.
2. But I took out one of them, so how many is left behind?
1.
Just one. So that's why we have a 2x
Oh,
left on the inside. Okay? Now, we had a 1x here, but we took out 1x. And anytime we take out everything, we use a 1. That's just our placeholder. Okay? All right, so now let's look at plus negative 4x minus 2. Lucky. It's your turn. Negative 4x minus 2. What's my greatest common factor there?
4. 2.
So is it 4 or 2?
2.
Okay, why?
Because
Yeah, 4 is divisible by 2. Now, is 2 divisible by 4? No. So, 2 is, you can divide 2 by itself, and you can divide 4 by itself, so that tells us that for sure that's our greatest common factor, because it's one of the numbers. Now, what do you notice is in front of both of those numbers on this case?
negative.
Yeah, the negative. So we're actually going to take out the negative as well. So we got negative 4, we took out a negative 2. What's that leave us with here for x?
Positive 2x.
Positive 2x. You guys, make sure we're focused. Okay. And then we got a negative 2, we took out a negative 2. What's that leave us with here?
1.
1. Very good. All right. Now, at this point, we have a good indicator that we've done something right. Deshaun, look at this statement here and tell me why I am 100% sure that we have done it correctly.
Which one?
We're on step 5. They're both the same. So if you look in the parentheses, we've got 2x plus 1 here. We've got 2x plus 1 here. If we get the same thing and we've done the right steps, we can be confident that we've done the right thing. Now, what is significant about that 2x plus 1, Colin? What do we do with it?
You keep one of the 2x plus 1.
Yeah, you keep one of them because that's going to be one of your factors. Now, once you know that, what's the other factor?
1x minus 2.
1x minus 2. So whatever you had in common is one factor. Whatever you didn't have in common is the other factor. Good. All right. So we worked through that one together. Here's what I would like you to do. I'd like you all to take about 5 or 6 minutes, because I think that individually you can work through these quicker. And in your groups, work through the second and third examples. And we'll just get this part on the speed dial, okay? So work through these for about 5 minutes. If you have questions, I'll be around, and then we'll start our activity, okay? So you should be working on the problem 5x squared plus 33x plus 18. Yeah, this one. So you're going to find your A. This one. But you'll have to do that one too, so I mean, I guess it doesn't really matter what order you do. Go through the steps. Dave, you want to get started? What's wrong?
And then what do you do? Well, you don't need the square, just a number. Okay. All we're doing right now, and now we're multiplying a times c. We'll over the a and over the c. And 5 times 18 is 13. Check it. Yeah, you know that's the pair you want, so I mean, maybe we'll start. There we go. Okay, so once you get that, now you're going to find remember, 2 is a, there's c, 5 times 18. You multiply 8 times b. Now, you're going to find the factors of that number, whatever you try. We'll put on here. You want them to add up to 30. Do that. And the number that they add up to, you get from the All right, so you've got some factors. Here's what you do. Instead of going all the way to this bottom right now, go over here onto the other side. Repeat those same steps so that you get to that part, and then we'll move on to it. Okay? So do this piece, and then over here, do the first piece. Okay. I'll be right over, okay? Sarah, you doing okay? Andy, you good? Yeah, you're already okay. Tracy, you okay? Okay, let's get this. So use the right factors. Now, you took out your 1x. Now, it looks like you both wrote 8 here. Do you have to pull these things together? No, you just leave them separate. So you pull out your 1x, like you had. And you get 5x squared plus 3x. Hey, Mackenzie, I'll be over as soon as I go to Bill. Okay? Thank you. So we got 5x squared plus 3x. So really, we just take an x off. So there we have 2 x's. Now we've got the number of the and then what about here? So all you did was actually just take out. So you want to roll individually. So you get a 30 and 18. What's not 3 is not better. 18 is 30. So look for the biggest number that's in the 30 and 18. So divide this number. See what you can find the biggest number that's in 30 and 18. So you're trying to get a 5. Okay, Cindy and Rebecca. Okay, Cindy's on the next one. What's going on over here?
Look, right here. Is that right? Is the one down there? Because I don't have it to go.
Okay, 30 and 18. Do you know a number that they're both divisible?
No.
They are both divisible by 2. Here, let's check it. First, let's find factors of 30. Okay? So we got 30 divided by 1 is 30. Okay, that's cool. 30 divided by 2 is 15. 30 divided by 3 is 10. 30 divided by 4, 7.5. So that's not a factor. 30 divided by 5, 6. Okay, so we got a 6. 30 divided by 6 is 5. So that tells us that we can stop whenever you get the two numbers right next to each other. So we've got a couple of factors that we could potentially try. We've got 1, 2, 15, 3, 10, 5, and 6. Now, of those numbers, which ones do you know that 18 is also divisible? It's divisible by 3 and 6. But if we're looking for the greatest common factor, which one would we take out? 6. So instead of putting a 1 here, we can actually take out a 6.
I think find which one can be divisible by each other.
Yep. And then since you took a 6 out here,
That'd be 6 right
okay, now, oh, that's backwards. You should have a 1x plus 6. But, now we got to look at what we get left. Okay, we had a 30 and we divided it by 6. What did 30 then become? 5. So now instead of a 30x, we got a 5x. Now what about the 18? What happens when you divided it by 6? Yeah. 3. Now, how do we know for sure that that 5x and that 3 are correct? Compare them to something else on the page.
This.
Yeah. We were looking for a 5x plus 3. We got it.
So this one would be 5x plus 3.
Yeah. So that's just your way of checking to make sure that you're on the right spot. If you look at these two factors that you have left behind and they're not the same, that tells you that you need to go back and look at one and see what else you can take out. Okay? We go over here.
Am I doing this right?
I hope so. Let's look at it. 33. You are doing fine until right here. See how we got 5x squared and 3? Do they have any numbers in common that you can divide them both by? No. 1. So should that be a 3?
No.
No, it should just be a 1. Now, here you're going to do something similar. You're going to look at 30 and 18, see what you can divide both of them by. And then put that out. Okay?
Oh, okay.
But you want the biggest one. So
Okay,
make
is
sure
it on this right there?
yeah, those are completely right. This, you just need to change that and then go ahead and finish. Okay?
Oh, okay.
Thank you. Yeah, because you know you're trying to multiply them to get a positive number, but add them up to a negative. So that's good. Good job. Okay, the 120 is positive, but we know we're going to add up to negative numbers. Now, what are 2 ways that we can get a positive number if you multiply? You can do a negative times a negative or a
You can divide
positive times a positive, right?
negative and a third, right?
Which case do you use for this one? If you use a positive times a positive, you add them over, you're ever going to get negative 23. Positive 2 plus positive 3 always makes a bigger, right? So in order for it to be negative, it has to not be the positive case. Is it the negative case? Okay, so negative 1, negative 1, negative 120 makes it negative 1. So basically, you got all the factor pairs that you need. What do you have to do? Yeah, maybe negative, and then all of a sudden, one of them will pop out. 4. So now you're ready to find your greatest common factor from 5x squared to 30x. And then you're ready to find 20.
So it's 4. It's negative 4.
Not 6. Well, yeah, the 6 is what you get when you divide the 30 by 5. But they actually have a 5 in them because they're really divisible by 5. What's 5 divided by 5? What's 30 divided by 5? And then what did we take out? What did we take out? We took out 8. Because that's what we divided by. So that means that. Now look here. We got 3x plus 18. Yeah, there you go. Good job. Good save. There we go. Good. All right. I'm going to take a second, and I'm going to go ahead and pass out the activity because it looks like some of you have finished up the notes, but some of you need more time. Okay, the way this works. Can I get your attention for just a second? Give me 5 and look up here, please. Okay, the way this factoring puzzle works, it's got problems, like it's got, for instance, x squared plus 4x plus 4. It's got problems, and then it's got factorizations. What you're going to do, you're going to look for the problems, the trinomials, and you're going to factor them.
after you get all of them factored, I'm going to give you some scissors if we have time still, and you can cut it out, and whenever you do it, it'll make a puzzle that fits together in a square. So it's already a square, but you'll reorganize it so that it goes together to where you've got the problem next to its factorization. So you'll pick all these up, like for instance, if I had x squared plus 4x plus 4, that factors into x plus 2, x plus 2. So I would find x plus 2, which is right here, and then those pieces would go together. Okay? That if you get stuck with that or have trouble with it, just let me know and I'll clarify it for you once we get to that point. But for right now, I want you to focus on finding the factorization. Now, this has got 3 different kinds of factorizations on it. It's got what we're doing today. It's got the a not equal to 1. It's got what we did on Monday and Tuesday, where you just had the parentheses and you just went for it with the x's. There was only a 1 in front, the easier version. And then it's also got greatest common factor, which is what we did before spring break. That might be the one that actually trips us up just because it's been so long. Okay, so I'm going to pass these out. If you haven't finished your guided notes, filling in the blanks, go ahead and do that. If you have, go ahead and get started on this, okay? I should have offered you that. I'm sorry. Bless your heart, you're just standing there. All right. Let's see, Sean. No, we should divide them on both last year. That's the same question we had. And then over here, you do the same thing, but now you know for sure you're looking for 3. Well, how do you get 3 out of 16? How do you get 4 out of 20? So what does that tell you? Yeah, you can move it there. Isn't it a good color? I'm telling you. You know, Betty Boop, like a lot of people say it's very 90s, but what can I say? No, it's, you never go through a woman's process. That's the problem. Well, these are all good pieces of advice. Okay. So Teresa wanted to move up here so you all can work on these together. I would suggest, since there's so many problems, a divide and conquer strategy. Like maybe like Timber works on these, or maybe Rebecca works on these. Good to go?
Oh gosh, she's not going to be amazing.
Well, let's make sure we're focused, okay? Right now.
No.
You'll be all right. Now, if you need some blank paper, I know that one of these sheets has some blank.
That's going to be so awkward.
Okay, so Rebecca, you're going to take the top part. Cindy, I'd like for you to take these 4.
Oh yeah, that's what we're gonna do.
Teresa, take the bottom 3, and then you all can close those. Okay. I need to see you working with them. Don't get all the way crazy. Okay. Thank you.
And see what you take out. Take out like simple. One. What?
I'll be right back.
I don't know what I see. Oh, that's 2. And it's 2. X minus 4. Do what, bro? What, bro? I'm going on the outside, bro.
Yeah, so it's like, so you'll have a factorization somewhere. Like, you are working on the trinomials, and eventually one of these is going to factor into that.
Uh-oh. 5 and 2 goes in together.
Which, in this case, is unfortunately 1.
So it has to be plus.
But in general, like let's say you worked out this problem, there's going to be one of these factorizations that matches that, and then whenever you go to cut them out, those are what you're going to match up. Just a second, I'll be right back. What do you need?
one is paper. I messed up.
Negative 12 plus negative 11. Okay, that's cool, but watch what happens when you multiply 12 and 11.
Then you get 140.
132. Are we looking for 132?
That was close.
Okay, so that's not quite your factor here yet. So keep going. Let's see, you got 4, 5, 6, 8.
I don't.
You're trying to get a positive 120. You multiply negative 30 times positive, or that's going to be a positive? No. So what do your factors have to be? Which one is it? And why do we need to have negative? What would it have to add up to? Negative 23. Are you ever going to be able to add up to positive or to negative? Right, not unless you're right. See, okay. So you're never going to be able to add up two positives, so you're going to be negative, so that angle has to be negative. So if you make this one negative, this one negative, this one negative, and then when you add those up, you'll see the 15 plus 8.
Yeah.
So keep working. Thank you.
Hey, look, how did I do this? 5 and negative 2 don't go into nothing together, except for 1.
5 and negative 2.
Yeah? What you got right there?
So you look for factors. Okay, you got your negative 6 plus 1. You got a 1x minus 2. Okay, that's right. So you got your grouping. Go for here. Now, here's a big question. What are 3 and 6, or what are they both in the middle? 3. So you can put a 3 there instead of just a 1, right? And then that means that you did a 3 divided by 3, so what's usually left on the other side?
1x.
Minus
6. No, 3. Yeah, 3.
Careful, you need to ask yourself 6 divided by what number?
3.
Which is?
3.
So 6 divided by 3 is 3.
Yeah. No, 2.
There you go.
Hey,
3 plus 3 is 6, but not 3 times 3. So you got a 1x minus 2. Now, does that 1x minus 2 look familiar from anywhere else?
Yeah, right there.
Right there. So that tells you here, you're not going to take anything out except your placeholder, which is 1.
So then it'd be 1, or you see 1 minus 2.
1x minus 2. Don't forget your x's. The reason I asked you to do that is because, let's say you went back and looked at it. Would you remember, like tomorrow, that there was an x there that you just didn't put? Probably not. And you go 1 minus 2 is negative 1. But since they're not like terms, you need to combine them. So you always got to make sure you're talking to your
So this is the answer, right? Let me see.
Well,
So it goes 1 negative 2. That's 1. And the other one is. And the other one was 3x plus.
So now that factorization should be around here somewhere. You can match it up.
So.
I'll give you a hint.
And
And that gives you an indicator that you did it right. If it's not there, it's not right.
so what do I count?
Well, okay, so you'll make the note that that equals that. So put your factorization real close to it, that way you're not using too much space. And then what happens is, you might have to do this tomorrow, because I think we're going to run out of
Here,
time.
I got a plan. Watch this.
Yeah, we're going to run out of time on that. But what you can do, okay, what will happen is you cut it out, and then you'll be able to match these two up. It's going to make it square. We'll put it in our folder, we'll finish it. Well, not tomorrow, Monday. Okay, how we doing over here?
Oh, I'm done, son. Dude, I want one more week. Wake up. Yeah.
This one here, 4x squared plus 1. Okay, whenever it's only got 2 terms, it's obviously not like what we should do, right? These are the ones where you go back and you factor. Like we say 4 is 2 times 2 times 2 times 2.
Coffee is so good. I don't like coffee. If I do get coffee, it has to be like really sugar coffee. Like sugar.
That's the method for that. So, I would recommend just while that's going back and trying something like this. Just try that problem and see if you can get that. That's not going to help you on your quiz every day, but it is from your exam with revenue. Hey guys, can we make sure we're on topic, please? Rebecca. Thank you. Say what? Wouldn't the bigger number be a negative? Wouldn't the bigger number be a negative? Why? Yeah, because you're trying to get a negative. Well, no. Here, they're not both not just the bigger numbers are negative. We're trying to multiply them together to make a positive. If just one of them is negative, we are going to get a positive number. We are trying to get a negative. But we not just one negative. Like not one negative. You multiply positive and negative. Yeah, if you've got one positive and one negative, that makes it negative. If you're trying to get a positive 1.44. So you want the factors of 144 that add up to negative 24. Yes. But whenever you multiply them, you get a positive. We know they're both going to be positive, so you add those up.
Put it right next to your face.
So what does that mean both factors have to be? Negative. Negative. So you're going to look for a negative number times a negative number. So that whenever you multiply, you get 140. Basically, you're going to do the same steps that you've been doing with the factors. You're just going to make them all negative. So that should be a negative. You just write the answer next to the problem. That way, whenever you cut it out, you can match them up. Okay. Is it up for you, please?
I haven't done like 5 things in like 50 years.
Sorry.
Yeah, it's 4.
Let's look. Got most of this one.
Yeah, you can write 10 colors.
Do you see what these have in common?
And you get in the car though? Yeah, you can get in a car, like random cars on the street.
Hey, Dylan.
What?
I'm going to get back on task.
Talking about like doing mathematical to break into a car.
No, you said something about ramming a car into a door.
What?
Well, while I won't argue that there's some mathematics there, I don't think it's this mathematics.
We think mathematics is a break the lock. Like if it's a code field that do with mathematics.
There is a field for that. It's called cryptography. And if you get good at math, you can go to college for that specifically. It's called street mathematics. And then you can work for the NSA or the FBI.
Actually, I work for the FBI.
You'll have to get a clearance first, so you'll make sure not to get arrested. Okay. So you got 5x.
I'm so tired. I got a project. I got to hear my project.
But you got to present it, so you look for what.
Yeah, but I'm not doing it. All I have is a school.
Hey guys, if you're having trouble staying on task, here's what I need you to do. We've got about 4 minutes left in class. Guys, give me 5. Look over here, please. Mackenzie, can I see your eyes? Ishmael? Okay. If you'll notice at the bottom of your bell worksheet, it's got an exit slip place.
I already did it.
If you've already done it, that's fine. These are what I'm going to be looking at to make sure that you've understood the concept today. So go ahead and start working on that problem individually. 6x squared minus 11x minus 10. I want you to find a factorization of it, show all of your work, all of your steps, and I'll bring around your folders here in just a second so that we can make sure everything gets taken up, okay? Thank you.
forgot how to do that. Wait.
As you finish up, go ahead and make sure, give you instructions what you be doing. Where's it at? Okay. Go ahead and get started with the problem. I need to see what you can do. Dylan, where's your exit slow at? Okay, thank you.
Right there. I'm done.
Hey, Silas.
Right there.
There you go. Silas. Both of you can sit up for your exit.
Oh, okay. Let's just say what the
Go. Get up. Calm down. I need you to work out this problem. Okay. Yeah, I don't know what that's. It is a little scary. Yeah. I think this calculator's had it. If you push a second, you will fix it. You know how like you have a car and you have to put duct tape on the headlight? It's also work and you want to steal the thing. That's that calculator. I wish you could have seen my old car. Okay, it looks like we've got about 1 more minute. So be finishing up, and as soon as you can, go ahead and put your papers in your folders, and go ahead and start getting the calculator straightened up, okay? Hey Dylan, if you're finished, could you go ahead and start straightening up so that they can keep working?
Oh.